So let me be more specific. Let's look at the following 4 points, 2 blue and 2 red, and 2 models that classify them, the one on the left and the one on the right. Quick, which model looks better? You are correct. The model on the right is much better, since it classifies the 4 points correctly, whereas the model on the left gets 2 points correctly and 2 points incorrectly. But let's see why the model on the right is better from the probability perspective. And by that, we'll show you that the arrangement in the right is much more likely to happen than the one in the left. So let's recall that our prediction is y hat equals sigmoid of wx plus b, and that is precisely the probability of a point being labeled positive, which means blue. So for the points in the figure, let's say the model tells us that the probability of being blue are 0.9, 0.6, 0.3, and 0.2. Notice that the points in the blue region are much more likely to be blue, and the points in the red region are much less likely to be blue. Now obviously the probability of being red is 1 minus the probability of being blue. So in this case, the probabilities of the points being red are 0.1, 0.4, 0.7, and 0.8. Now what we want to do is we want to calculate the probability that the 4 points are of the colors that they actually are. This means the probability that the 2 red points are red and that the 2 blue points are blue. Now if we assume that the colors of the points are independent events, then the probability for the whole arrangement is the product of the probabilities of the 4 points. This is equal to 0.1 times 0.6 times 0.7 times 0.2, which is 0.0084. This is very small, it's less than 1%. What we mean by this is that if the model is given by these probability spaces, then the probability that the points are of these colors is 0.0084. Now let's do this for both models. As we saw, the model on the left tells us that the probabilities of these points being of those colors is 0.0084. If we do the same thing for the model on the right, let's say we get that the probabilities of the 2 points in the right being blue are 0.7 and 0.9, and of the 2 points in the left being red are 0.8 and 0.6. When we multiply these, we get 0.3024, which is around 30%. This is much higher than 0.0084. Thus, we confirm that the model on the right is better because it makes the arrangement of the points much more likely to have those colors. So now what we do is the following. We start from the bad model and calculate the probabilities that the points are those colors. Multiply them, and we obtain that the total probability is 0.0084. Now, if we just had a way to maximize this probability, we could increase it all the way to 0.3024. Thus, our new goal becomes precisely that, to maximize this probability. This method, as we stated before, is called maximum likelihood.